Hello, this is part three of integral chapter tests. So we're going to continue on the integration test, and this will be the last part. So let's start on 28. We have the integration of dx over x times square root of 5 minus x squared. So what do you think this is? Do you think it's a u substitution? So I think we'll have to use u equals 5 minus x squared. Do you think that's a u substitution? I don't think so, because if you take the derivative of that, you get negative 2x dx. The x is on the bottom, so that will not work. But I think it is some kind of substitution, but it's a trig substitution, right? So I see that you have 5 minus x squared. You know it's related to this, right? And then we know that x is going to be a over b times sine of theta. So what do you think our a is going to be in our b? So I think our a is going to be square root of x, and my b is going to be 1. So that means it's a equals a, which is square root of x, and b is 1 times it by sine of theta. So x is going to be square root of x sine of theta. And then my dx is going to be, what's the derivative of this? It is, oops, I made a mistake. My a is not square root of x, it's square root of 5. Okay, so now you know how to take the derivative of this. Square root of 5 is a constant, so you just take that out and really just take the derivative of sine of theta, which is positive cosine of theta. So dx is square root of 5 cosine theta d theta. Okay, so then let's continue. So we're going to have the integration of 1, and then we said our x was uh, square root of 5 sine of theta. So you're going to replace this x with 5 times, square root of 5 sine of theta times square root of 5 minus x squared. That is going to be square root of 5 minus, and then we said we're going to replace x with this whole thing. So it's going to be square root of 5 sine theta, and then we got to square that, right? Okay, so, and also times, oh, then you replace, don't forget you replace this dx with this. So you could times that on the top or in the center, that's fine. So if you want to, this simplifies as, you could put this on the top now. And then when you square this, and then you subtract the 5, so when you square a radical, that's 5, and when you square a sine theta, it's sine squared theta. So, so really, it's just square root of 5 minus 5 sine squared theta. Okay. And then you simplify. So over here, what can you take out? I think you could take out a 5, right? So I would factor out a 5, so it's going to be square root of 5. And then this is going to be 1 minus sine square theta d theta. Let's see here. So yeah, you could take out this 5. So now to square root of 5. And 1 minus sine square theta is an identity. It's one of your trig Pythagorean identities, right? So I guess you can replace 1 minus sine square theta with cosine square theta. And then if you take out this 5, it's not a perfect, square root of 5 is not perfect. It's just square root of 5 times, and then you can replace this. So this is still under a square root. You can replace 1 minus sine square theta with cosine square theta. So really that's just square root of 5, and then the square root of cosine square theta is cosine theta. So if you clean this up a bit, you have square root of 5, and then you also have this extra square root of 5. And then you have cosine theta on the bottom. And then it's all about canceling. So oops, also forgot this extra sine theta, so bring that down as well. So yeah, it's all about canceling. So this cancels, this cancels. Now you're left with 1 over square root of 5 sine theta d theta. Okay, and then 1 over square root of 5 is a constant, so you may take that out. And we know that 1 over sine theta could be simplified as cosecant theta. And what is the integration of cosecant theta? That's something you should know. It is negative ln of the absolute value of cosecant theta plus cotan theta plus c, and then you have this constant of 1 over radical 5. So this could be simplified as, so you have a minus here, so you could say negative 1 over square root of 5. Let's see. Is this our final answer? No, we're not. Our final answer has to be in terms of x. We have it in theta, right? So what do we got to do? We got to plug in, we have to resubstitute. So we said a while back, we said x was radical 5 sine theta, right? So we were given x equals radical 5 sine theta. Let's kind of solve for sine theta. So, because we want it in terms, yeah, in x. So let's get sine theta by itself. So I would have to get rid of this radical 5 by dividing both sides by radical 5. You get sine theta is x over radical 5, right? Now, this is where you need to like draw your triangle, or it's like the SOHCAHTOA thing, or that if that helps. So if you draw your triangle, let's pretend here's theta, and we have sine theta, which is over h, or so this x is like your opposite, and then this radical 5 is like your hypotenuse. So you would ratify here, and then here's theta. The opposite side would be here. And we got to find this missing leg by using Pythagorean theorem. So if you do that, a squared plus b squared equals c squared. A, I don't know what that is. B could be x squared. And then c is radical 5 squared, which is 5. And then solve for a, so you're going to subtract x squared. A squared equals 5 minus x squared. Take the square root of both sides. We get a is square root 5 minus x squared. Okay. So what we need is cosecant theta, cotan theta. Let's figure that out real quick. So cosecant CSC theta is, what is it? There's an S in the middle, so it's the reciprocal of sine. So the reciprocal of sine, we were given that. The reciprocal of that would be radical 5 over x. And then cotan theta is x over y. So my x is square root of 5 minus x squared. And my y is the x. Okay, so our final answer will be negative 1/5 ln of the absolute value of cosecant theta, which is radical 5 over x, plus the cotan theta is square root of 5 minus x squared over x plus c. Okay, so yeah, this technique is the trig substitution method. Okay, let's move on to 29. 29, we have the integration with no boundaries. Wait, did I put a plus c on the very end? Yes. So 29, there's no boundary. It's 1 over x squared times square root of 16x squared minus 9. So I don't think it's a U substitution. I think it's a trig substitution, right? So this square root of 16x squared minus 9 is very similar to this bx squared minus a squared, right? And that is going to be, and then your x is going to be a over b of secant theta. Okay. So what we need to do is figure out our x, and we need to figure out our a and our b. So my x is going to be what? I think our x is going to be, so my a is related to the 9. So it's going to be, what number squared gives you 9? 3. And my b is related to the 16. So what number squared gives you 16? 4. So a over b, so that's 3 over 4 of secant theta, right? So that's my x. Now let's find our dx. How do I take the derivative of 3/4 times secant theta? Well, 3/4 is a constant. So really just factor that out, and then really take the derivative of secant theta, which is secant theta times tan theta. So clean this up a bit, plug in, substitute what we need. So it's going to be 1 over, and we can replace x squared. Well, we know that x is 3/4 secant theta. So it's going to be 3/4 secant theta squared. And then it's going to be times square root of 16 x squared, which is 3/4 secant theta squared minus 9. And then replace our dx with this dx right here with 3/4 secant theta tan theta. Okay, so if you kind of clean this up, this is going to be, you could put this right here on the numerator if you like. And then clean this up. What is 3/4 secant theta squared? That is 9/16 secant squared theta times what is 3/4 secant theta squared? That is going to be, so times it by 16 is going to be 9/16 secant squared theta. And then this minus 9 is outside, so put it outside, but still inside the radical. Okay, clean this up. Okay, so 16 times this whole thing, you FOIL this out, the 16 cancels, so you're left with 9. Yeah, 16 times 9/6 is 9 secant squared theta. And then you have this minus 9. And you still have this d theta right here. Okay, clean this up a bit more. So over here, you can factor out a 9. So that's going to be 9 secant squared theta minus 1. And let's see, we know that the square root of 9 is 3. And then, so you can take that out. And then you have the square root of secant squared theta minus 1. So this is a Pythagorean identity. We know that tan squared theta plus 1 equals the secant squared theta. And if we subtract 1 from both sides, we get tan squared theta equals the secant squared theta minus 1. So you may replace this with tan squared theta. And we know that the square root of tan squared theta is just tan theta. Okay, so let's clean this up a bit. And then I guess you could, this whole thing now just becomes 3 tan theta. Let's see, now it's all about canceling. What can we cancel? We can cancel these tan thetas. And so now on the top, you're left with you're still left with, oh, you can also cancel the secant theta. So now this becomes a 1. So now you're left with d theta. On the top, you're left with 3/4. And then on the bottom, you're still left with this 9/16 and this 3. So if you multiply that out, that's 27/16. And now you're left with 1 secant theta. And don't forget your d theta. Okay, over here we kind of have a complex fraction, 3/4 over 27/16 if you want. That's the same thing as 3/4 divided by 27/16. And if you cross multiply, you're going to get 4/9. So we can write this right here can be simplified as 4/9. And then we have secant theta, d theta. Okay. Let's simplify the constant. 4/9 is a constant. You could put that outside. And then you're left with 1 over secant theta, d theta. Let's simplify this. What's 1 over secant theta? Well, I know that it's 1 over, and then secant theta can be expressed as 1 over cosine theta, right? And that simplifies as 1 divided by 1 over cosine theta. You cross multiply, it's cosine theta over 1. So this whole thing, 1 over secant theta, is simplified as cosine theta. Okay, can this be our answer? So, wait, no. What's the integration of cosine theta? It's positive sine theta, so you get 4/9 sine theta. Let's see. Can this be our final answer? No, right? We have it in terms of theta. We need it in terms of x. So we need in terms of x, not theta. So this is where you're going to draw your triangle. Here's theta, and then use what we have. So we know, okay, so what we know is we know that we were given x. You go up here, we said that x was equal to 3/4 secant theta, right? So x equals 3/4 secant theta. And let's get secant theta by itself. So I got to get rid of this 3/4. To do so, I'm going to multiply both sides by 4/3. Okay, so this is going to be secant theta. And then 4/3 times x is 4x over 3. And, okay, so now what we know is we can plug in, we can do our SOHCAHTOA thing. So to draw a triangle. So secant is a reciprocal of cosine. So if cosine is adjacent over hypotenuse, the reciprocal of that will be hypotenuse over adjacent, right? So this 4x is your hypotenuse. This 3 is your adjacent. Okay. Now we got to find this missing leg by applying Pythagorean theorem. So it's going to be 3 squared plus b squared equals c squared. So 3 squared is 9, b squared, 4x squared is 16x squared. And then solve for b, so you're going to subtract 9. I get b squared equals to 16x squared minus 9. Solve for b. You get 16x squared minus 9. So b is square root of 16x squared minus 9. Okay. Now what we need is we need to find sine theta. But based on our triangle, sine theta is opposite over hypotenuse, right? The opposite is square root of 16x squared minus 9, and then my hypotenuse is 4x. So our final answer right here, it's going to be 4/9. And then we found sine theta, which is this. And then you have this 4x plus c. And you can just write it out. Let's see, you can cancel the 4's. So now your final answer will be square root 16x squared minus 9 over 9x. And don't forget the plus c. Okay. So this is another problem involving trig substitution. Okay. Let's do another one. Okay, 30, we have to take the integration from 0 to 1 of square root of x squared plus 1 with dx. So I think it is another trig substitution, but the only difference is we have boundaries. So x squared plus 1, does that look familiar? Anything that looks familiar? Yes. It's very similar to square root of a squared plus b squared x squared, where the x is going to be a over b of tan theta, right? So, yeah, let's figure out our a and our b. So I think our a is going to be, so our a is related to this one, right? See, our a is the constant. So what number squared gives you 1? 1. And our b, so our b is related to this x squared, but our b is the number in front of the x squared. There's no number, that means there's invisible 2. So that means, invisible 1, not 2. So my b is still also 1. So x is a over b, so 1 over 1 times tan theta. But really, it's just x equals tan theta. Okay, and then we take the dx. What's the derivative of tan theta? It is secant square theta d theta. Okay, so our boundary is going to be from 0 to 1, and we're going to replace, what are we going to replace? We're going to replace x with tan theta, but there's a square, so it's going to be that's going to be tan square theta, and then we'll leave the plus 1 alone. And then we're going to replace our dx with this. Okay, and then we'll use some of our identities to make it easier. So tan square theta plus 1, that is one of your Pythagorean identities, and that equals to secant square theta. And then this stays the same. What can we do? So we can simplify even more. We know that the square root of secant square theta is now just regular secant theta. And then secant theta times secant square theta d theta is secant cubed. Okay, let's change our boundaries. Our original boundaries are from 0 to 1. I don't want to use those boundaries. So if x is to our lower boundary, if x equals 0, And we said that x equals tan theta. So it's like saying 0 equals tan theta. So what degree in radians is going to give you a tangent of 0? That is pi over 4. 0, no, 0, right? So theta is going to be 0. And if x equals 1, that's really saying 1 equals tan of theta. So what this is really saying is what degrees in radians is going to give you a tangent of positive 1. That's pi over 4. Okay, so we just changed our boundary. So it's now going to be from 0 to pi over 4. And we still have this secant cube theta, d theta. I don't think we can do a u substitution. Let's just rewrite it as secant square theta times secant theta. How are we to take the integration of this? So it's two things that are multiplying, so that's a big clue. We're going to do integration by parts. Or annihilate. So what do you think our u and what do you think our dv is going to be? So I think our u is going to be secant theta, and my dv is the leftover, which is secant square theta d theta, right? And my du is going to be the derivative of secant theta is secant theta tan theta. And my v is the integration of secant square theta d theta. And what is the integration of secant square theta? That is just tan theta. So v equals tan theta. So continuing with integration by parts, it's uv minus the integration of v du. So our u is secant theta, so it's going to be written as 0 to pi over 4 and then we just did this, that was integration by parts, that's going to be uv minus v du. So it's going to be secant theta tan theta minus the integration of v du. So my v is tan theta, and my du is secant theta tan theta d theta. And what can we do? So over here, you have a tan theta times tan theta, so that would be tan square theta. And tan square theta times secant theta simplifies as secant square theta minus 1. Okay. So if we simplify this, this is going to be secant theta tan theta minus the integration of secant square theta minus 1. And then my d theta is and then you still have this extra secant theta. Wait. So tan square theta is secant square theta minus 1, and then you still have this secant theta d theta. Okay, clean this up. So this is going to be secant cubed minus secant theta So, okay, then we got to plug in our boundaries. I mean, our integration. So we're going to write it out as from 0 to pi over 3 and pi over 4 of secant cube theta d theta is equal to secant theta tan theta minus the integration from 0 to pi over 4 secant cube theta d theta plus the integration from 0 to pi over 4 of secant theta d theta. And then because you have a repeat somewhere here, right? You do have a repeat, so you can just add this to the other side. So you can say plus from the integration from 0 to pi over 4 of secant q theta d theta from both sides. Okay, so now you have over here, now you have two of them, so you could say 2, 0, pi over 4 secant cube theta d theta equals to secant theta tan theta. What's the integration of secant theta d theta? Okay, so clean this up. So this is still going to be this. And this is still going to be secant theta tan theta plus what's the integration? Oh, it's from 0 to pi over 4. What is the integration of secant theta d theta? It is the ln of the absolute value of secant theta plus tan theta. And then we do have boundaries, so you got to do up 0 to pi over 4. So that's going to simplify as ln of the absolute value secant of pi over 4 plus tan of pi over 4 minus bracket, and then do your lower boundary. It's going to be ln of secant 0 plus tan 0 and when you put it all together, you're going to get this. It's going to be radical 2 times 1 plus ln of the absolute value square root of 2 plus 1 minus bracket 1 times 0 plus ln of 1 plus 0. And you get radical 2 plus ln of the square root of 2 plus 1 minus 1. And when you clean it up more, it's going to give you 1/2 square root of 2 plus ln of the absolute value of square root of 2 plus 1 absolute value. Okay, that was a long one. That was trig and integration by parts, so it was a lot. Okay, let's move on to 31. Oh, yeah, let's just move on to I think still part 4. So let's move on to 31. So we have the integration from 0 to 4 of ln of x over square root of x dx. So can we do u substitution? I don't think so. But we can do, if you put 0 inside the square root of 0, square root of x, that gives you undefined, right? So it looks like we have some kind of improper integral. So is this going to be the limit as a approaches 0 to the right, from 0 to 4? So we can rewrite this as a limit problem. So 0 to the right. We can say the limit as a approaches 0 to the right, from 0 to 4, or a to 4, of the ln of x over square root of x of dx. And we can use ILATE. So we're going to do integration by parts now. So my u is going to be ln of x, and my du is going to be 1 over x dx. My dv is going to be 1 over square root of x dx. And my v is the integration of this, which is 1 over square root of x dx. And then you can rewrite 1 over square root of x as x to the negative 1/2 dx. So my v is going to be 2 square root of x. Okay. Okay, so then you apply integration by parts, so uv minus the integration of v du. So it's going to be the limit as a approaches 0 to the right of ln of x times 2 square root of x minus the integration of v du. So it's 2 square root of x and then 1 over x dx. So this simplifies as, let's see, 2 square root of x is the same thing as 2x to the 1/2, and then over x to the 1 dx, and then old power minus 1, so 1/2 minus 1, or 2 over 2 is negative 1/2. That's going to be 2x to the negative 1/2 dx. So that's going to be ln of x times 2 square root of x minus, so you can say the limit as a approaches 0 to the right of 2 square root of x ln of x minus the integration of 2x to the negative 1/2 dx. And then it's going to be the limit as a approaches 0 to the right, 2 radical x ln of x minus the integration of this is going to be, let's see, it's old power minus 1, so negative 1/2 plus 1. It's going to be x to the 1/2 over 1/2, which is 2x to the 1/2. And then we're going from a to 4. Yes, a to 4. So it's going to be the limit as a approaches 0 to the right, and then apply your upper and your lower. So it's going to be 2 square root of 4 ln of 4 minus 4 square root of 4 minus 2 square root of a ln of a minus 4 square root of a. So the limit is going to be a approaches 0 to the right of 4 ln of 4 minus 8 minus 2 square root of a ln of a plus 4 square root of a. And if you recall, this graph of square root of a would look like this. It's a square root graph like that. And the graph of a natural log looks something like this. It has a vertical asymptote at 0, and it looks something like this. So we'll kind of need that to find the limit. So it's going to be 4 ln of 4 minus 8 minus 2, and then the yes, when you plug in 0, square root of 0 is 0, so it's 2 times 0 times it by ln of a. So what is the limit as x approaches 0 to the right of this graph? It's infinity, negative infinity plus 4, and then square root of a or square root of 0. And when you put it all together, you should get 4 ln of 4 minus 8. We can stop here. Well, there's only a few more problems left, and then that'll be it.